Fusion Mobile, quality e-learning experience on the go.
Now let's go to the soil composition. Soil in itself is a mixture. Soil comprises of various materials that are put together on the surface of the soil. And we have 5 components of the soil. We have the inorganic or mineral matter. We have the organic matter. We have the soil water. We have the soil air. We equally have the living organisms. These 5 are together composed the soil. Let's look at them one after the other. The inorganic matter of the soil. This refers to the mineral material inside the soil, which are the elements like the nitrogen, the oxygen, the calcium, the magnesium, the sulfur, all these mineral elements that are present in the soil, which the plant requires for healthy growth. They are called the inorganic matter of the soil. In actuality, it is this mineral matter that is formed from weathering. Where you break rock down to form soil, the component that you are breaking, which you can see with your eyes, that form the soil, that's the mineral matter. Inside of it, you now have invisible elements like calcium, like sulfur. You have them inside. So that's the mineral component. The component of the soil that is formed from weathering, that's mineral matter. And it is this mineral matter that performs the major role of the soil. A part is one that gives space for water, that gives space for air, gives space for living organisms, that even gives space for the organic materials. The inorganic matter of the soil, it is the one that helps in the anchoring of the roots of the plants. It is inside the inorganic matter that we plant the crops. It helps in anchoring, in holding the plant roots to the soil. It also helps in retaining water for the plant. It helps in retaining air for the plant. Living organisms, they live inside this mineral matter of the soil. Now, from the mineral matter, in terms of percentage by volume, the mineral matter occupies 45% of the total volume of the soil. 45% of total volume of the soil. Now, move to organic matter. The organic matter, these are the ones that are formed after the soil has been formed by weathering. Then the animal remains, plant remains, the refuse that are dropped on the surface of the soil, the dead plants and animals, when they now decompose, they now form organic matter, which is also called humus. This humus will settle on top of the soil. This is what gives fresh nutrients to the plants that are crops that are planted on the soil. The organic matter is made of 5% of the soil. Organic matter improves the water holding capacity of the soil, ability of the soil to hold water. The organic matter improves the fertility, the organic content of the soil. It enhances speedy growth of crops. The organic matter also increases the capillarity ability of the soil, the ability of the water to pull water of the soil to pull water up. It helps the porosity of the soil. So the organic matter is very, very essential. It is the organic matter that makes loamy soil to be the best type of soil. Whenever organic matter is present in the soil becomes loamy. It improves the agricultural capacity of the soil. Then we have the third one called soil water. Soil water, this refers to the soil that the water that occupies the pore spaces in the soil. Now, soil being a mixture, soil is a mixture, has a lot of particles. Now, in between these particles, you have some spaces. The spaces are called pore spaces. These pore spaces can either be occupied by air or occupied by water. When it's occupied by water, it's called soil water. When it's occupied by air, it's called soil air. Now, this water that occupy the water sometimes might not be visible, but they are inside the soil. So that water is called soil water. Now, whenever there is air inside the soil, the air is normally there's air inside the soil. It's called soil air. Except during acute rainy season, when the rain is too much and all the air has been displaced, there's no longer any air. The soil becomes waterlogged. But shortly after that, the water will begin to find its way into the soil and run off to the ocean, creating fresh space in the soil that air must occupy. So both air and water, they share the pore space of the soil. Now you have living organisms in the soil. These living organisms, they are the one living inside the soil, like I've mentioned, under the factor affecting soil weathering. Organisms like earthworm, like termites, like rodents, like even microbes, like bacteria, all these organisms, they live inside the soil. The soil water and soil air, the percentage by volume of each of them is 25%, making 100%. But living organisms is variable because living organisms are mobile. They can move from place to another. You cannot totally trap them down. And again, sometimes living organisms, when they are dead, they produce organic matter, which is 5%. So we take them as being variable. The whole bulk of volume now becomes 100%. But there's something to mention under soil water. Under soil water. Okay, before we go to under soil water, we can represent again this by a pie chart. Pie means circle, a chart means diagram. So we can draw a circle diagram to illustrate the percentage by weight by volume of soil. Now, percentage by volume of soil, we have mineral matter that takes the chunk of the volume, 45%. Then we have the soil water, 25%. We have this is quarter, 25% of soil air. Then we have just 5% for organic matter. The living organisms, they are variable. Now we can look at the types of soil water. There are different types. Though water is the same, but we call them different names when they're in the water, in the soil, depending how they come there and the work they do. The first one is hygroscopic water. Hygroscopic water. Hygroscopic water, these are the water that occupies the fine particles of the soil. They bond soil particles together. When you dig the soil and the soil is coming out, the soil will not come out like a powder. It will come out like gari. It will come out in form of crumbs, in form of clods. They will hold together. The water that hold them together is called hygroscopic water. That hygroscopic water cannot be removed. Plants cannot use it. The only way you can remove hygroscopic water is by heating the soil to temperature that's higher than 100 degrees. Then all the water will escape. The next one is capillarity water. The word capillary is upward movement of water in the soil. Capillary water is water that rises up above the water table and that is available for crops nutrients. A lot of crops will take water from the soil, from their root, they pull it up. This water is called capillarity water. Then we have gravitational water. The word gravitational is pulled to the earth. So when it rains and water settles on the top, so this water will be pulled down to the earth by gravity. That water is called gravitational water, and that water is available for crops. Crops can use it. The fourth one is called field capacity. Field capacity refer to the amount of water remaining in the soil after flood, when the excess water has been removed by drainage. In other words, if you have flood and everywhere is waterlogged, water has filled everywhere, but you are able to remove all the excess water on the soil, the flood, you're able to clear it by drainage. Water will still be remaining in the soil, and that water will just fill the soil. The excess on top has been removed. That water that is in the soil that filled the soil, that water is called field capacity. And that field capacity is available for crops uptake. There are other things that we need to mention there. There's something we call wilting point. Wilting point. Wilting point is the amount of water remaining in the soil when the plant begins to dry up due to lack of enough water. Now, we know when you plant crops need to obtain water in the soil for turgidity, for cellular growth and development. But whenever the water is not enough from the soil and the roots cannot pick the water, the plants begin to dry up. Now, when plants begin to dry up, the amount of water in that soil during which plants begin to dry up is called wilting point. If you quickly apply water by irrigation to the soil, the plant will resuscitate, will come alive again, and they continue to grow. The next one is permanent wilting point. Permanent wilting point. Permanent wilting point. Okay. Permanent wilting point is the amount of water in the soil during which the plant has wilted or dry up and cannot recover again, even when water is applied. Okay. Now there's a level that the plant will get, the root will dry, the stem will begin to dry because there is no water in the soil. If water is quickly brought, then it may revive. That is wilting point. But if it has got to a level that the water has totally dry up and the plant has suffered drastically, and now you put water, the plant will not be able to recover. That is what we call permanent wilting point.